Okay there, kiddies. I think I'm totally losing it. 7.4 notes, kids. My name is Mr. Krause. Almost all of these videos, actually all of these videos, can be found at Infinity.com. Myself and my partner, Miss Vicky Newman, are here to assist you. Educators, if you'd like copies of these, send us an email. We'll talk. Anyway, let's get going. 6 trigonometric functions. 6? Why couldn't they just have 1 or 2? They gotta have 6. All right, so 6 trig functions. Let's talk about those. Now, all I really want you to do here is fill these in with opposite, adjacent, hypotenuse, and all that stuff. So go ahead, do it. You can pause me. Pause me. I just gave you a crazy face to look at. All right, 2 crazy faces. All right, let's go. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Some old horse caught another horse taking oats away. Kind of dumb. Some old hippie caught another hippie tripping on alligators. You decide. Some old hippo caught another hippo tripping on alligators. The hippie one ends with a little drug reference, which we won't go into right now. And then these are the reciprocal functions. The reciprocal functions. So this would be hypotenuse over opposite. This would be hypotenuse over adjacent. This would be adjacent over opposite. Simple stuff. Get it in your brain, bros and girls. All right, let's get moving on this stuff. We talked about the unit circle. What are the things we got to remember about the unit circle? What are our points? This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. This is the point 0, negative 1. You need to know this is 90 degrees. This is 180 degrees. This is 270 degrees. This is 0 or 360 degrees. Those are called quadrantal angles. We talked about our 30, 60, 90 reference triangle. 60, 30. We use 2 here. And then opposite the small 30 degrees is 1, and opposite the 60 is the square root of 3. And we also modified it for the unit circle by dividing each of these by 2. Remember that? But that's only for the unit circle. Then we also did a 45, 45, 90 right triangle where we, again, made the hypotenuse 2 and made each of these the square root of 2. All right, so determining quadrants. This is not bad stuff, kids. Here's how it works. It probably is in your best interest to write all students take calculus. So what does this information tells us? What does this information tell us? This tells us that sine is negative. I don't care that it's 1/4. I don't care at all. I care that it's negative. And I say to myself, where is sine negative? Well, sine is positive in the first quadrant, positive in the second quadrant, because I got a sign there, so it must be negative down here. And remember, sine goes with the y values, and aren't y values negative down here? They are. So down below, y's are negative. Now, what is this information telling us? This information is telling us that cosine is negative. Well, cosine is negative over here. Well, it's positive in the first quadrant and this quadrant, but we don't care about that. We want to care where it's negative. It's negative in the second, and it's negative in the third. And remember, it's where cosine is less than 0, or where x is less than 0. Excuse me. So, which quadrant is the big winner? Right there. Where do I have my 2 check marks? I have my check mark where sine is negative and where cosine is negative. So this would be quadrant 3. So you should be able to try that one on your own here real quick. Ka-ching, ka-ching. All students take calculus, or whatever fun little mnemonic device you came up with. It's probably not school appropriate. You probably shouldn't be using it, but use that one in calculus. Calculus is appropriate. You should be taking calculus. Whew. Got my anger out there. So where is sine positive? Sine's positive in the first quadrant. Sine's positive in the second quadrant. Where is cosine negative? Cosine's negative in the second quadrant and in the fourth quadrant. Big winner, quadrant 2. All right, pause it for a second, see if you can try this one on your own. Where did it go? I had a oh, there it is. You try. I covered it up. You try. Oh, man, I made this so easy on you. All students take calculus. All right. Where is sine positive? Ka-ching, ka-ching. Where is cosine positive? Ka-ching, ka-ching. Quadrant 1, big winner. All right, moving on. So now comes the craziness, the hard stuff, the whack-out stuff, the willy crazy stuff. So here's what we're going to do. First and foremost, we have to come up with the 6 trig functions. So I'm going to do 2 right away with no work. Sine is the square root of 2 over 2. Therefore, cosecant, which is its reciprocal function, is just 2 over the square root of 2. Can't leave it like that. You got to multiply by radical 2 over radical 2. So you get 2 radical 2 over 2, which is just radical 2. Woo! Hopefully you're getting good at that stuff. But we got to come up with, those are the ones I was given. Basically, I was given that information right here. So how the heck am I going to find out what cosine of theta is, which appears to be an impossible task, and then this weird thing called tangent of theta, which appears to even be a more impossible task, and cotangent theta. So I got my work cut out for me. So what I'm going to do, let me blow this up. Let's see what we got. We were told that sine is equal to the square root of 3 over 2, or square root of 2 over 2, and we're in the second quadrant. These are the 2 important pieces. Now, I don't care the fact, well, okay, this case it's actually pretty easy. I want to work in the second quadrant. Now, in order to do this work, you need to create a reference angle. And wait, as a matter of fact, let's call it what it really is going to be in this case. It's a reference triangle. Before I do that, we're going to create a reference angle in the second quadrant. And then we'll create the reference triangle. So let me create a reference angle in the second quadrant. Now, it doesn't have to be perfect, doesn't have to be exact, but we're going to do reference angle in the second quadrant. Now, what do we got here? We got, this is my angle theta. So this is what theta is. There it is right there. Now, there's my angle. Now, I drew it in the second quadrant because I was told it was in second quadrant, and I said it has to be a reference triangle, which means it either has to be made with 180 or 360. 180, 360. You know what happens when you do it with 90 and 270? You get a couple of these. Oh, I'm not kidding. Oh, okay, I'm just kidding. Maybe. So, what do I know about sine? I know that sine is opposite over hypotenuse. Well, how does that help me out? Well, this is the opposite side, and this is the hypotenuse side. And you've seen this before, square root of 2 and 2. Now, it should come as no surprise, then, that this is also going to be the square root of 2. We've worked with this triangle in the past. If you don't know that, you could go through the Pythagorean theorem. The square root of 2 squared plus x squared equals 2 squared, and you can get 2 plus x squared equals 4, x squared equals 2, and x equals the square root of 2. But we knew that already. I didn't have to, now, in this case, we didn't have to go through this work. We will have to go through it in the future. So how am I going to get the other 3? Well, let's hold on a second there, kids. What we got to do is we got to figure out. Dunkin' Donuts, my coffee's empty. This video is going downhill and downhill quickly, and it's all your fault. How about sponsoring the old guy, huh? Giving you all these free commercials. All right, let's keep going. Okay, what I was talking about before I went on my little pause there for a second and stopped the video was the fact that we're in the third quadrant, and I got to remember as I come to the left, the x values are going to be negative. So that's going to help us out. We want to make sure we use that. Okay, how are we going to do this? All right. So cosine is well, I probably ought to. label this. This is my hypotenuse. This is opposite, which we've already determined. And of course, this is adjacent. So I'm all set. I'm ready to go. Now these are easy. Adjacent over hypotenuse. Negative radical 2 over 2. Tangent. The square root of 2 over negative radical 2, which is really just negative 1. Now, cosecant is just the reciprocal of these. So this is going to be 2 over negative radical 2. Now, based on our work up here, we should know that this is just going to be negative radical 2. And you're going to get used to that. You'll get used to that. It's a little bit easier. And the reciprocal of negative 1, guess what? Is just negative 1. Wow, that was simple. That wasn't bad. All right, so here's what we got. We got cosine is 1/4, and we're in the fourth quadrant. Now, we knew we had to be in the first or fourth. So what we're going to do is create a reference triangle in the fourth quadrant. There it is right there. And there's my reference angle, always made with either 0 or 360. The only information I was given is cosine, which is adjacent over hypotenuse. Well, maybe what I need to do is label this bad boy. Hypotenuse. Remember, if this is my angle, then this is opposite over here, and this is adjacent. So let's label this thing. Adjacent, which is 1, over hypotenuse, which is 4. So this is one of those cases where I don't know what opposite is. So let's just call this, I don't know, let's just call it x. How am I going to find x? All right. Well, okay. I don't like calling that x because it's really a y value. Let's call it y then. So 1 squared plus y squared equals 4 squared. Okay. 1 plus y squared equals 16. Y squared equals 15. Y equals the square root of 15. So this is really just, and let me just get rid of this so I can see it better, is really just the square root of 15. But we're in the fourth quadrant, we're coming down, so let's make it negative. Okay, we're ready to rock and roll. Let's get our 6 trig functions down. Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. I just like doing that. It's fun. Anyway, wait, we were given cosine. That's 1 over 4. Cosecant, or secant, is just the reciprocal of that, which is 4 over 1, or just 4. So that we were given. The rest of them we kind of got to find. All right, so let's do this. Sine is opposite over hypotenuse. Negative radical 15 over 4. Well, the reciprocal of that is sort of a pain in the neck. It's going to be negative 4 over radical 15. I just don't like putting negatives in the denominator. Now, you can't leave it like that, my kids. You have to actually rationalize the denominator by multiplying by the square root of 15 over the square root of 15. So you get negative 4 square roots of 15 over 15. So that's actually what that one's equivalent to. That's the exact value. Don't start punching that stuff in your calculator and give me them dumb decimal values. Drive me crazy. All right, tangent is opposite over adjacent. Okay, square root of 15, it's negative, over 1, which is just negative square root of 15. And this is going to be 1, really negative 1, over the square root of 15, which we have to rationalize. You're going to get good at rationalizing the square root of 15 over the square root of 15, and I get negative radical 15 over 15. All right, that's it. All right. Oh, sorry. Misunderstood the question. All right, so here we go. I don't like the fact that I don't have my hand here. Anybody want to guess why Mr. Krause went into mathematics and not art? There is my hand. That's just crazy. All right. So let's see what we got. We got 1 finger to the left, 3 fingers to the right, 1 finger to the left, 3 fingers to the right. So that tells us our reference angle is going to be 60 degrees. But we are in the third quadrant. Now, I know we're in the third quadrant because they're both negative. So we're down here, both negative, with a reference angle of 60 degrees. So my reference angle is 60 degrees. I don't know. It didn't ask for that, but I gave it to me. So I know that the cosine value is -1/2. And the sine value is negative radical 3 over 2. Now, how does that help us out? So we need to come up with the six trig functions. Sine theta equals cosine theta equals. I actually thought the question asked, and I apologize, what angle measure? What angle measure will we have? We'd have 240 degrees if I hit, So really what we're talking about is 240 degrees. What are we going to? Cosecant theta. Secant theta and cotangent theta. All right. So sine is the y value, negative radical 3 over 2. So this is negative 2 over radical 3, which we multiply by radical 3 over radical 3. I get negative 2 radical 3 over 3. Cosine is just -1/2. So the sine is, or the secant is just -2. Now remember when we did tangent, I just want these numbers. So even though it's 1/2 and radical 3 over 2, I don't care about the 2's. So remember, tangent is y over x. So this would be the square root of 3 over 1. And then this would be 1 over the square root of 3 times radical 3 over radical 3. I get radical 3 over 3. Remember, in the third quadrant, tangent is positive. And when I divide these two y values, I get positive. All right, radical 2 over 2. So, again, going with our hand, what is that? All right, at least it's got 5 phalanges. All right, we're going to get rid of the second finger because notice I got 2 to the left and I got 2 to the right. All right, so sine, you should know this is going to be a 45-degree reference angle. We are in the second quadrant because x is negative and y is positive. So this is 45 degrees. If they ever asked you what the angle was, it would be this one, right? 135. That would be 180 minus the reference angle of 45 degrees. But that's not what they asked for. They want the 6 trigonometric functions. So we're going to do sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Now, having done the little hand trick, I know that this is radical 2 over 2. Sine is, it's the y value. And if I reciprocate this, I hope by now you just realize that's the square root of 2. This is negative square root of 2 over 2. And if I reciprocate that, I get -2, square root of 2. Tangent is, remember, even though these are the square root of 2 over 2 and the square root of 2 over 2, remember, we don't need these denominators. So really what it is the square root of 2 over the square root of 2. But since it's negative, one of them's negative, we know this is really -1. And if I take the reciprocal of that, I get -1. Hopefully that kind of makes sense. That was on a you try. I did it, you did it. All right. Maybe I should just put hands in there to make it out. I might put hands in on that before I hand it out to kids, because clearly me drawing hands is not such a good idea. So here's where you earn your money, kids. Here's where you earn your money. If 8, -1 is a point on the terminal, the ending side, of an angle theta in standard position, evaluate the 6 trigonometric functions. What? You know, some kids are going to sit there and just look at it and go, I don't know what to do. And I said, okay, what's the only thing you were given? A point. So the first thing you probably want to do is graph that point. Now, it doesn't have to be perfect, kids. We're coming out 8. We're going down 15. How about right there? That's the point, 8, 15. Well, what else was I given? I was told that this is an angle in standard position, so there's my initial side. It's going around, and this point is on the terminal side. Okay. Now, we've never worked with angles out here, so why start now? What I want is to work with this angle. All right, so far I've gotten to where I need to be. I got a triangle, but I don't have any of the side lengths. I don't even know how to find the side lengths. How do I find those side lengths? Oh, wait, this is negative 15. Oh, wait a second. I came out 8. So that has to be 8. And I went down 15, so that has to be negative 15. So can't I find the hypotenuse? Oh, yeah, that's not bad. 8 squared plus negative 15 squared equals x squared. No, don't use x. How about we use h for hypotenuse squared? Let's see, 64 plus 225 equals h squared. 289 equals h squared, so h equals, I believe that's 17. So now we know the hypotenuse is 17. Well, I'm good to go now, kiddies. I'm ready to rock and roll and rock. So sine, cosine. In fact, this one's going to be so easy because I don't have any of those stupid radicals to worry about rationalizing with. What do I got? Cosecant. Remember, we hated you guys, so we decided to mix the letters up. Secant. I almost wrote sine. And cotangent. Remember, that's not cot, and this is not sin. So, sine is... well, let me get rid of all the extra crap that I have in this triangle. Oops. And this was 8. All right, so I should probably label this opposite, hypotenuse, adjacent. So sine is negative 15 over 17. Okay, this is negative 17 over 15. Cosine is adjacent over hypotenuse. Okay, 8 over 17. Oops, 17. Secant, 17 over 8. Tangent, opposite over adjacent. Negative 15 over 8. Negative 8 over 15, just reciprocals. Wow, that wasn't so bad at all. I could do that. All right, you try it. Now, if you're just going to sit here and watch me perform like a monkey, I'll go like this for you. I'm not your performing monkey, kids. Pause the video, try it on your own. It's not good enough just to watch me. I just went through a problem. Plot the point, make the triangle, find the sides, get the 6 trig functions. There you go. So why are you still watching me, huh? I asked you, why? Pause the video, boys and girls. Okay, you paused it. Good. Okay, we're back. Okay, sorry about the lecture. Negative 7, 2. Negative 7, 2. Right there. It's on the terminal side of my angle, so I'll make my triangle. There it is. There's my triangle. I know I came out negative 7. I came out negative 2. I don't know what the hypotenuse is. So, negative 2 squared plus negative 7 squared equals my hypotenuse squared. 4 plus 49 equals hypotenuse squared. Don't write 53. 53 goes over here, equals hypotenuse squared. So that means the hypotenuse is a very annoying square root of 53. And it can't be reduced. It's just the square root of 53. It's annoying. It's not difficult. It's just annoying. It's sort of like a couple of students of mine. You know who you're talking about, MC. Just kidding, bro. Yay. All right, so sine of theta equals cosine of theta equals tangent of theta equals... No, I don't want to put secant here because that would be math teachers being nice to students and matching the S's together and the C's together. We were not. So we chose not to do that. I don't know actually who chose it, but I like that guy. Okay, probably should label my diagram. There's my opposite, there's my hypotenuse, and there's my adjacent. All right, so sine is opposite over hypotenuse. Oh gosh, -2 over the square root of 53. Multiplying by the square root of 53 over the square root of 53, I get -2 square roots of 53 over 53. That was a pain in the neck. Now the good news is, let me go back and just take the reciprocal of this. It's negative square root of 53 over 2. So that was actually pretty easy. I could just do that. Cosine is -7 over the square root over the square root of 53. And I think by now you realize that's just going to be -7 square roots of 53 over 53. I'm not going to go through that math. Take the reciprocal of this. So that's negative square root of 53 over 7. Now, tangent's easy. It's just opposite over adjacent. It's -2 over -7. Do not leave it like that. It's 2 sevens. And the cotangent is just the reciprocal, 7/2. Ka-ching! I think that's it. What do we got? Know your reference triangles, which of course just means reference angles. Really understand those reference angles. Know where to find those at. You got to know your unit circle. And exact values. So oftentimes we'll have some teachers that will say, hey, draw a bow tie in a quadrant. This is what Miss Newman wrote down. I'm not exactly sure what she's getting at, but what I like to say is if I want to draw, I know, see, here's what she say. She says draw a bow tie. So she does this, draw a bow tie. So there's my bow tie. Now, why do I draw a bow tie? A bow tie gives me 4 reference triangles. Now, that's actually a very horrible drawing. So based on my crazy fingers drawing, you probably thought, oh, that might be pretty good. But let's see if I can make this better. So I want to draw a bow tie. So if I draw an accurate bow tie, I have 4 reference triangles, which means those will be the 4 angles. Those are all you need to work with. Don't mess with the y-axis. This is off limits. Off limits. Not allowed, okay? Don't draw it. All right, kids, that's it. That's all she wrote for day 4. Hopefully you got a little bit out of this. Try that homework. Get working on it. Hit the subscribe button. Hit the like button. Send me a comment. Let me know what you think. If you don't know where I got this little hand thing from, search Mr. Krause Math. Or just search NK Infinity and hand trick. Left hand trick. Kendrick Krause left hand trick. Maybe I'll put a link in the show notes if I remember to do so. Otherwise, just search for my YouTube channel. Subscribe. You'll get all the videos. All right, guys. Catch you on the flip side.